Okay, so we were talking about how we can classify shapes. For example, triangles, we can classify them either by their side lengths or we can classify them by their angles. Now, in terms of what we've been doing, we've been able to calculate the length between any two given points. So if you're given what three vertices in a triangle are equal to, you could figure out if it's scalene, isosceles, or equilateral by calculating side lengths. And to get side lengths, you're really using this distance formula to find the distance between the vertices in your triangle. So for example, if you were given that you had some triangles and its coordinates are A, B, and C, you could calculate the distance between point A and B, and then calculate the distance or the length between B and C, and calculate the length between A and C. If they're all different, you know it's scalene. If they're two are the same, so scalene is all are different. If two are the same and the third one's different, it's isosceles. And if all three are the same lengths, then you know it's equilateral. So it's just side lengths that you need to find to classify them as isosceles, equilateral, or scalene. Now, if you want to decide if it's right-angled or not, we did this the other day with a question. We know that two sides must meet at 90 degrees, and that implies, therefore, the slopes of the two sides must be negative reciprocals of each other. So to prove it's right-angled, we don't need the distance formula. What we need is the slope formula. Okay, so we're going to calculate the slope between each pair of points with that slope formula. And we want to see if there are two of the slopes that are negative reciprocals of each other. So just remember, a negative reciprocal just means, like, let's say you had the slope of, oops, let me try another pen here. How do we undo? Undo. There we go. I got to go back to my pen tool. There we go. Let's say you found the slope of A to B, and that was equal to, let's say, 1/4. And then you had the slope of B to C, so another side in the triangle, and if that was equal to -4, so these two have the opposite sign and they're reciprocals of each other, because -4 really is -4/1, which is the flip of 1/4. If you have that happening, then you know those two sides are perpendicular to each other. So they do create a right angle, and it is a right angle triangle. So that's what you're looking for with that one. All right, next, classifying your quadrilaterals. If you know the coordinates of the four vertices of your quadrilateral, so you are given like A, B, C, and D, you can use lengths and slopes to classify them as a parallelogram, rectangle, square, rhombus, or kite. So for example, let's say you have some kind of a four-sided figure and you know the coordinates of A, B, C, and D. You can use the length formula or slope formula to show different things. Now, one thing to note, and I've put it on the other side of the paper, is that when we name quadrilaterals, we label their vertices in order. So you'll notice that if you look how I ordered this, A goes to B, goes to C, goes to D, goes back to A. So we're labeling them kind of in a circular fashion. If they gave you that you had quadrilateral A, B, C, D, you would never join A, C, B, D. You wouldn't join them that way, because if we're talking about A, B, C, D, that implies A joins to B, B joins to C, C joins to D, and then D goes back to A. So that would be incorrect if we did A to C, C to B, B to D. So keep that in mind when you're creating your quadrilaterals, or any polygon for that matter. Okay, so question 2, if you're given the coordinates of the four vertices of the quadrilateral, what calculations would you perform to prove that the quadrilateral is a parallelogram? So we know for a parallelogram that opposite sides must be parallel to each other. Okay, so if you had quadrilateral ABCD, you would want to show that AB is parallel to DC, and then you would want to find that or show that BC is parallel to AD. So you're really calculating the slope of each side. So find the slope of AB, the slope of BC, slope of CD, slope of DA with your slope formula, and you need to show then that opposite sides have slopes that are equal to each other. Okay, So keep that in mind. Now to show that you have a rectangle is a special type of parallelogram. Your opposite sides must be parallel to each other, just like with a parallelogram. So you still need to calculate the slope of each side and see that opposite sides have equal slopes. But the thing that makes it different from just being a regular parallelogram is that adjacent sides have to make a 90-degree angle. So not only do you have to have slopes that are opposite to each other being equal, you also have to have sides that are adjacent or beside each other, connected to each other. You need to show that they form a right angle, that their slopes are negative reciprocals of each other. Now with a square is just like the rectangle, so you still have to do your slopes. Opposite sides have to be parallel, adjacent sides have to meet at 90 degrees, plus, so this extra to this, plus all sides are equal length. So not only do you need to calculate slopes to prove it's a square, you need to do everything as you would for the rectangle, plus you have to check to see if a pair of adjacent sides are the same length. Now you can calculate all four lengths if you wish, but if you've already proven they're parallel, then if you just show that the adjacent sides are equal in length, by default, because they're parallel, the rest will be equal in length as well. Okay, the rhombus. The rhombus is like a special parallelogram. So you still have that opposite sides are parallel, but along with that, so that means we need to calculate slopes, and opposite sides have to have the same slopes. All sides have to be equal length. So we're going to calculate slopes with our slope formula to see if opposite sides have equal slopes, but then we also need to check the side lengths to see if they're equal. So your side length formula, just for the blue, you know that your side length formula is right here. This is your side length formula. So this you would use here and you would use here to calculate your side lengths. Your adjacent, for a kite is a different shape. You have a side lengths beside each other that are adjacent, because they're beside, they're called adjacent. They have to be the same length, and then the other pair of adjacent sides. So it's not opposite sides that are the same length, it's the adjacent sides. So two pairs of adjacent sides. All you need to do for kite is just check your side lengths, and the sides next to each other should be equal to each other in length. So keep that in mind for working through your questions today. Next slide. So here's our example that I was hoping you would do for homework yesterday. Given these three vertices, you're supposed to verify or show that this is a right angle triangle. So right angle, I know two slopes have to be negative reciprocals of each other. So I calculated the slope of AB and got a slope of 1/5. I calculated the slope of BC and got a slope of negative 1/3. They're not negative reciprocals. And then I calculated the slope of AC and I got the slope of 1, which is also not a negative reciprocal. So actually I've shown that it's not a right angle triangle since there are no sides whose slopes are negative reciprocals of each other. This is not a right angle triangle. Okay, so, and we did prove one the other day that was a right angle triangle, I think a couple classes ago, maybe in 2.3. Question number 4, given these four vertices, so here's a case where we have the four vertices. We've got P, Q, R, and S. We're going to verify that PQRS, and remember this tells us what order to join those in, is a rhombus. So rhombus has opposite sides that are parallel to each other, and we have adjacent sides being equal to each other. So what I calculated was the slope of PQ. So here's that note about when naming the polygon, how these things are ordered together. So P joins to Q, Q joins to R joins to S, and S joins back to P. So I found the slope of PQ was 2/3, the slope of QR was negative 2/3, the slope of RS was 2/3. So these two sides, PQRS, these two sides, if I label my points, PQRS, in that circular fashion, we have found that PQ, right here, is parallel to RS, SR or RS, and we've also found that QR was a slope of negative 2/3. Now, my diagram is definitely not to scale because negative slopes should go the other direction. But we found that these are opposite to each other and they're equal to each other. The next thing, so we've proven it's a parallelogram. To prove it's a rhombus, we now have to add in the fact that we have adjacent sides that are equal length. So I used my length formula and found the length of PQ. I found the length of QR. So these are adjacent sides. PQ is here, QR is here, and we found those are equal in length. By default, the others will be equal, but I've actually calculated them here just to show you that all sides are equal length. So it is a rhombus because we have opposite sides equaling slopes, and all sides are equal in length. Okay, the last question. We have, what type of quadrilateral is ABCD? So it's telling us we're joining A to B to C to D, given the coordinates here. So I have no idea, but I know slope will tell me a lot about this. So I calculated the slopes, and again, I'm creating my quadrilateral. Let's try that again. Creating my quadrilateral, we have A to B to C to D. And totally not to scale, not on a grid. I just want to organize my information. So I've labeled it in a cycle, in a cyclical manner, around in a clockwise or counterclockwise fashion, as long as it goes in a circle. I found the slope of AB. Slope of AB was 3 over 4. So slope of AB is 3 over 4. So there's my 3 over 4. I have my slope of BC being negative 4 over 3. BC is negative 4 over 3. CD is 3 over 4. So CD is parallel to AB. So there's one pair of opposite sides that are parallel, the same slope. And then we have AD being parallel to BC because their slopes are the same. Okay, notice that they're the same. So since opposite sides are parallel, same slopes, and adjacent sides have slopes that are negative reciprocals of each other, meaning they meet at 90 degrees. So do you notice that this one is 3/4, but this is negative 4 over 3? They are negative reciprocals of each other. Negative reciprocal, negative reciprocal. So all our sides are meeting at 90 degrees. So it's either going to be a rectangle or a square. We've got 90-degree angles now. So we know we've got 90 degrees. Okay, and we know we've got opposite sides being parallel. Now, we need to check our side lengths to see, does this actually make a square or does it make just a rectangle? So I found the length, the distance between point A and B, which gave me 45 units, and then I found the distance between B and C, which is only 30 units. So these are not the same side lengths. So based on that, this is not a square, this is a rectangle. So since the side lengths are different, I forgot to write this in. I think I got interrupted when I wrote this out at school. Since the sides have different lengths, this is a rectangle. Okay, I already wrote a statement up earlier here about the slope, so I knew it was either a rectangle or a square. Since the sides have different lengths, it is a, dang it, is a rectangle. Okay, good luck working on your questions. Let me know if you need some help.